Imagine tumbling helplessly into a monstrous abyss, a void devouring everything in its path. As you cross the precipice, the universe itself seems to warp around you, bending light and time to its will. Space becomes a viscous fluid, engulfing you in a tunnel of darkness. The laws of physics distort beyond recognition, no longer reliable guides in this strange new realm. Any screams of terror are silenced instantaneously. Nothing seems able to escape. You have entered a place of ultimate chaos, the lair of the cosmic beast, known as a black hole. These monstrous collapsed stars represent one of the most mystifying phenomena in our universe. Born in the aftermath of a supernova explosion, black holes exert a gravitational pull so intense that nothing, not even light, can break free. The star's mass creates significant disruptions to the space-time continuum. As you drift closer to the edge of a black hole, gravitational forces begin to stretch your body like putty. Feet accelerating faster than your head, you are pulled into a thin strand of matter. This tidal force effect is also known as spaghettification. Now, before we enter the black hole, there are other factors to consider. The immense gravity doesn't just distort space, but also time itself. This leads us to one of the most mind-bending aspects of black holes, time dilation. To illustrate this concept, let's consider a scenario where a planet closely orbits a black hole and you're part of a two-person astronaut team. One of you descends to the planet while the other stays aboard the spaceship orbiting further away. Due to the intense gravitational field, time would pass more slowly on the planet than for the astronaut in the spaceship. Time dilation occurs because the flow of time is affected by gravity. Specifically, time flows more slowly near strong gravitational fields, like those around black holes. This effect can be derived from Einstein's theory of general relativity, which relates gravity to the curvature of space-time. The stronger the gravitational field, the more space-time is curved. Clocks tick slower in regions of space-time that are highly curved or warped by gravity. Consider a specific example. Let's say the astronaut stays on the planet for 24 hours. Since the planet is very close to the black hole, it would be immersed in its strong gravitational field, forcing time to flow at a different rate relative to the other astronaut on the spaceship. The clock ticking on the spacecraft would literally tick faster than it would for the astronaut on the planet. The significant time dilation near a black hole would lead to shocking contradictions for astronauts. If the astronaut remained on the planet for a single day, they would return to their colleague, who would be long dead. Hundreds of years would have passed for the other astronaut or any other observers further away from the black hole. This dilation is like pausing time itself. The flow of time was slowed to a near halt for the planet-side astronaut relative to their colleague. Time dilation is not just theoretical, but has been conclusively observed. Atomic clocks orbit the Earth at high speeds and show minuscule time gaps compared to stationary clocks on the surface, proving gravity does alter the flow of time. Near black holes, these distortions are carried to an extreme. Now let's continue the example and assume the remaining astronaut steers the ship directly into the black hole. According to Einstein's relativity, time would stop from an outside perspective. The ship would appear frozen at the horizon's edge, even as it continues falling inward. To the astronaut, time flows normally, but the universe outside might buzz through eons in the blink of his eye. What happens next is unknown. One hypothesis suggests that the immense gravity crushes the explorer into a singularity, a point of infinite density where space and time cease to exist. All that he ever was is compressed into a quantum oblivion. But perhaps even stranger fates await within. Some theories propose that black holes may harbor wormholes, hypothetical tunnels through the fabric of space-time. These cosmic shortcuts could transport the astronaut to different locations in our universe, or even entirely different planes of existence altogether. Emerging from a wormhole, they may gaze upon an alternate version of Earth, where history followed a separate thread. Or he may find himself in a baby universe just now sprouting into existence. Perhaps he'll be instantly vaporized in the churning chaos of a nascent cosmos. the deepest secrets of black holes remain out of reach. But one day, we may comprehend the mysteries lurking within these bottomless gravity pits. Will we find the crushed remains of lost souls, or gateways to realities far beyond our imaginations? For now, we can only wonder what profound revelations await future explorers when they travel into the unknown. Thanks for joining us on this journey through black holes. If you enjoyed this video, don't forget to like, share and subscribe for more fascinating trips into the cosmos. Until the next time.